In this video, I will show you how to use digital twin to simulate the physical robot. First, you need to add the connectivity in Visual Components and add OPC UA server connection in Visual Components. And then navigate to the variables and pair each of the variables with the OPC UA server. And I can show you how to change the values in the server and view the robot moving in the digital twin. And finally, I will showcase connecting with the physical robot. The OPC UA server and the client is running in an Ubuntu 18 virtual machine, and the visual component is running in the host machine, which is Windows 10. When you open the visual components software, the tabs here is only process, modeling, program, drawing, help, and there's no connectivity tab. You need to go to File, Options, Add-on in here to enable the connectivities. After you click the enable, you must choose the OK and close the software. After the software is restarted, the connectivity tab is showing here. This means the connectivity function is enabled. In the previous videos, we have shown you how to create the digital twin in Visual Components, and now you can load the files in Visual Components. In our case, in our file, we have created a digital twin of our physical robot, the Nachi robot. This is a standard 6-joint robot. And we should go to the Connectivities tab. And there's OPC UA function here. In here, we need to add the server here. When we try to add the server in Visual Components, we need to ensure the server is running, and also we need to ensure the Visual Component can connect with the server. In our case, we can check our IP address of the host machine in a terminal here. Open a terminal in the host machine, input IP configure, and we can find the IP address of the host machine is 10.0.0.101, and the mask is 255.255.255 and 0. Then we can go to the virtual machine, and our virtual machine is setting is the network is attached to the bridge adapter, so it can be a same network. And we open the virtual machine, and we open a terminal, input if configure. Then the IP address is 10.0.0.118 and the net mask is 255.255.255.0. So it is in the same network. And besides this, because we are using a Ubuntu system, we need to enable the Ubuntu firewall for our port 48020. So we need to input sudo ufw allow 48020, because this 48020 is our port number for OPC UA. You can choose your port number for your OPC UA, but I just show it here. Then we allow this port, so it's allowed here. Then you can go back to our Visual Component. Then we input this value. This is the same as here. Then we can apply, and we can go to here to connect. Then it shows true in the connect place. Then now we can choose the server to simulation. Right click, add variables, and this new window come out. In the right side, that is the window for the server values. In the objects, you can find the Nachi robot, Nachi joint, and these 6 joint values. This is the same as we created here. We create these six values in the Ubuntu server, and you can see it in the Visual Components. And in the left side, this is all the components for the digital twin you created in the visual component. And we found out our robot, the Nazi robot, is named MZ07. We find this behavior. Under the behavior is here, J1 here. We choose J1 and we choose this, then the pair can be choose here. Then we click pair. Then you see in this window, in the main window, this value is shows paired. And we go to the J2 here, J2, and this notch J2 pair, and we pair each of these 6 values here. After we pair each of these 6 values, then all this server to simulation value is shows here. Now we can click this play button to allow the visual component move according to the server variables. In our previous videos, we have created a OPC UA client. In this client, it will change the server values for 100 times. Then we can run this OPC UA client here. Then you see the value is changing. Then we can go back to this simulation. You see that in the digital twin, robot is moving. This moving is according to the server variables here. In this demo here, we have connected our system with the physical robot, and we run in the visual component simulation in the Windows PC, and connected the simulation to the server, and we run the UA expert in the same PC. Then I can configure the robot variables in the UA expert. During the test, I have changed the TCP value for the robot for several times, and the robot is moving according to the target position. The visual component is connecting to the robot current position. So when I change the wanted TCP values here, it will send the request to our inverse kinematics. It will convert the TCP value to the joint value. Then after the PID calculation, the joint value will send to the robot controller. It will drive the robot to the position. And also it will feed back the robot current value to the OPC UA server. So the simulation will move according to the current position.